Hello everyone, this is Oluwaseun Amuda from Gemma Training Institute, and today we'll be talking about multi-tier architecture with hands-on projects using AWS CloudFormation. So as I promised in the last video, so this is it. Remember to subscribe, it's very important so that you can receive new updates as new videos are being uploaded. So before we proceed, we have to know what a multi-tier architecture is. So think of it as plugging your device on different wall sockets at home, so the failure of one does not stop the running of the other. So that's instead of you using an extension to connect the TV together, you are plugging them on different wall sockets. So if this wall socket fails, this one is still running. So that's what it does. The failure of one piece does not stop the running of the other. And in terms of security, you trust me, you might plug this one in the city room. That's where anybody can just come in and take it. But this one, you want to plug it in your room, whereby it's safer, it's more safe. Yeah. So the same thing goes for the public subnet. That is, you put in data that even when breaking into, whenever it's been breaking into, you are less concerned about the security. So you might plug your lamp here and plug your phones here. So the security varies. So that's the main thing. So you can specify less security and more security depending on the importance of the information, because if the app has been breaking into, then you are highly concerned about security, about the data being exposed. So that's the benefit, that's the major benefit here. And so if you are designing a 3-tier architecture, so you have to specify the EC2 instance, that's your web server, on the public subnet. Then your app tier, you specify it also on the private subnet. You create another instance for it with different security group. Take note of that. Then database tier, another was private subnet with different security group. Now, what's a VPC? You know, everything together is a VPC. A VPC is just like the current source flowing to the extensions. So it's allows you to launch other AWS services in an isolated virtual network that you have defined. Think of it as your laptop, whereby you run things. So that's just the way it works. That's a VPC. Now subnets. So what are subnets? Subnets is just a breakdown of a VPC. That is, it breaks down the CIDR block into smaller range. So it specifies to each subnet. Now types of subnet, we have two types. We have the public subnet and the private subnet. I've mentioned it earlier. So the public subnet, it allows what? Internet traffic for users to access, while the private subnet does not allow internet traffic. That is, users cannot access it. So this is the public subnet right in here connected to the internet gateway. The internet gateway is used to allow a public EC2 instance to have access to the internet. That's the public subnet to have access to the internet. So yeah, as you can see in the CIDR block I was talking about, this 16 and this 24 is being broken down to smaller ones. The same thing goes for here. So actually the private subnet here now is not attached to the internet gateway. Rather, there's a security group for it that limits the activities of the inbound traffic entering. So it limits it. Now, what's an internet gateway? I've said an internet gateway allows the public subnet to have access to the internet. So the users can have access to your web tier. So that's the function of an internet gateway. But the NAT gateway, you know, we said the private subnet does not have access to the internet. So in a situation whereby you want your private subnet to receive updates, software updates from the internet, you use a NAT gateway. Take note, the users does not have access to the NAT gateway, to the EC2 instance in the private subnet, because you are using a NAT gateway. Rather, only the EC2 instance having access to a software update from the internet. But assuming you want users to have access to this private EC2 instance, then you have to use basting or a jumper. So basting is used in a situation whereby you want a user to have access to the private subnet. Now route table, you connect the route table to the public subnet, then you associate the route table to the public subnet, then the router is being connected to the internet gateway. So the router and the route table, the internet gateway. So the route table connects the internet gateway together. So that's just it. And this is a simple architecture of it. So these are internet gateway connected to the router. then it's connected to the what, the route table. It's associated to the route table here. So these are NAT gateway. Can you see the database instance is being associated through a NAT gateway to receive what, updates, and customize. You have to customize the route table so that it does not have access to the general instance. So that's it. That's the way it works. And if you are using a NAT gateway, you have to specify an elastic IP address whenever you want to use a NAT gateway. Now, auto scaling. So what do you understand by auto scaling? Auto scaling simply means an instance has been launched, but in a situation where there's high traffic or there's high workload on it, it automatically scales to relieve the system. That's what it does. So you can use a launch template or a launch configuration to create a new instance. As you automate a new instance whenever using launch template or launch configuration. But the launch configuration is an old form of creating new instances. So AWS recommend I use a launch template. Take note of that. So this is, as you can see, the launch instance template creates instances. Then you have to scale the instances depending on the workload. And they said the maximum capacity here is 2, the desired capacity is 2, the maximum capacity is 2. So what they mean by minimum is that even when there's no workload, 2 instances should be running. And by default, 2 instances should be running too. The maximum capacity, that is when the workload is very large, it cannot scale past 2 instances. So you reduce costs using this method. So that's what they do. That's what they did there. So no matter what, 2 instances will always be running. Even in the failure of one, can you see the failure of one and now is being created, this one will be terminated. So no matter what, 2 instances must always be running. It must not be more than 2 instances, and it must not be less than 2 instances here. Now, what do we understand by NACUS security groups? NACUS has related to subnets. So whenever they are talking about security of a subnet, you think of NACUS. So by default, they allow inbound and outbound or traffic, but they are stateless in the sense that once you allow a traffic inbound, it's not automatically allow outbound. So that's the meaning of stateless. So NACUS are stateless. But security group, they are stateful in the sense that traffic allowed inbound is automatically allowed outbound. So no matter what, if you allow a traffic inbound, automatically is allowed outbound. By default, all traffic are being denied in a security group. And security group deals with instances. Now your RDS just stores your database. That's what it does. It's always in a private subnet. So that's it. So that's what you need to know. And some projects, and let's take a look at some of the practical questions that we be putting into practice. So you are working with an AWS. You are working as an AWS Solution Architect for a large banking organization. The requirement is that under normal business hour, there would always be one web server up and running in a region. Example, US West Oregon. So here now we are dealing with a business organization. So we are dealing with a banking organization. So what they are talking about here is that their security is very important. You don't want your card details to be exposed. So you have to create security. The security has to be highly secured and highly available. So, and they said no matter what, one web server must always be up and running even during weekends. So they said if you have a 3-tier architecture, that's a multi-architecture connecting to the database, as you can see, the database stores the information. The solution offered should be highly available. It must be highly available. It must be secure because you don't want your card details to be exposed. It must be cost effective. That is, it must not be too expensive. At least you must minimize, in the sense that what they mean by cost effective here is that when there's no much workload, it should be able to auto scale. It should be able to scale down. That is scaling in a situation where the workload is not much, and should be able to respond to every request. So whenever there's an every request, it should be able to scale out. And latency, so the latency must also be reduced during peak hours. And database should be available, should be able to tolerate up to 1 AZ failure. That is, you have to create multiple, you have to enable multi-AZ. So multi-AZ, this with this, solve the problem of this. So let's go on to the practical session and see how we are going to go about it. So welcome back everybody. So this is the solution to the question. So we're told we have a 3-tier architecture. That's 1, 2, and 3. So one for the web server, one for the app tier, and one for the database. So that's it. And if you want to have something like this, you use Draw.io, because the Draw.io app, because you can't use this, the AWS designer cannot do this for you. So this is used to explain to your clients, make your client understand what you have actually done. So that's how you go for this. But if you are careless about that, then you just go with the AWS CloudFormation Designer. You see it soon. So now these are the codes. So these are metadata. Take note of that. Metadata is not really that important, but when you care about the arrangement of the template, when you want it to fall in an order, so you can just copy this metadata. The most important thing here is the resources and the parameter. So let's check out our resources. Now here we are, resources. Just like I said in the last video, I said the first thing you do is you create your VPC. So we create our VPC right in here. I will specify the setup block, enable DS support, and then its host name. Set it to true. So that's what you do. Then the next thing is you create your subnets. So we have 1, 2, 3, 4. We have 4 subnets, 1 public and 3 private. So this is it. On the public subnet, you mark what public IP on launch by default. It is always false. So you will notice that in the other subnets, you didn't specify them because defaults, they should be kept private. In the situation whenever you want them public, you specify them. So because this is a public subnet, you are specifying them. Availability zone US is 1A. So you are just picking out one availability zone for this and this too. So this one has two availability zone, one for the master RDS and the other one for the read replica, because they are talking about speed. So in terms of latency, wherever a user only wants to read, so it goes for this. This is being used instead. So this one is used for write majorly, and this one is used for read. So these are subnets. We specify them. Take note, your setup block must not overlap. As you can see, they are not overlapping. They are quite different from each other. This 1, this 2, and this 3. So once they overlap, it will bring out an error. So it won't create. Now once you are done with your subnet, the next thing you do is you create your internet gateway. So once you create the internet gateway, you use internet gateway attachment to attach it to the VPC, so that your VPC can have access to the internet. So once you have done that, you create your route table. So let's it. You create your public route table. Once you have created your public route table, you use the route to attach it to the internet gateway. So this is our public route table. You specify that it belongs to this VPC. Then the route, the destination setup block to the internet. So this is it. So specify the gateway ID. Then you associate it to the subnet using what subnet route table association. Now once you are done with that, you create your security group. We start with the instance creation and security group. So you create your security group for this. Then your auto-scaling group, your launch templates. Those are those you don't need to create a website because the launch template creates it for you. Then you associate a security group. You associate an auto-scaling group. So as you can see, this is a security group for the private subnets. That's why the port is from 0 to 6535535. And you specify that it belongs to this VPC. So whenever you're having more than one subnet, so you specify that it belongs to this VPC. And the auto-scaling group, as you can see, so we have shared this auto-scaling group to this launch template. So take note of that. So this is it. You can see to this launch template. And once we create two, one for this, one for this. So we are having it right in here. VPC zone identifier, that's the subnet. That's what they're talking about here. So we specify this. It's very important. It's required. Then the capacity. So they said at least in the question they said 1 must be running. So we have the desired capacity 1. And the minimum size to be 1. So maximum, whenever there's high low traffic, it should scale to 2. When traffic is low, it should scale back to 1. So that's it over there. And security group for the public subnet, we set from TCP from 8 port 80 to port 80. Side IP, so it's 0.000. Now, so that's it. Then we go to the RDS and come back to our database. So you create a database instance. So creating it, you specify this. All these codes for each resources, you can get it in the AWS resource CloudFormation resource, so you can get them there. If you check the previous video, you see the previous explanation on how to get all these things. Now you create a database subnet group, so that combines these two together. So this is it. You see private subnet 3 and private subnet 2. It combines them together so that they can work together as one. And you create a security group. So this one receive the writing IO, that's default, IOPS, that's input output per seconds, and this one does the reading. So by you notice that NACOs are not here. The reason why NACOs are not here is because NACOs are by default allows inbound and outbound traffic, so we don't just specify them, but you should have to specify a security group because by default they deny all traffic. Then we want our private subnets instances to update himself, automatic update, so you have to create a NAT gateway. So the NAT gateway allows the instance to have access to the internet so that it can update himself. And when creating a NAT gateway, you have to create an elastic IP address. So this is it. This is a NAT gateway. So create an elastic IP address right in here, then we specify it in the NAT gateway. And parameters. This CloudFormation, and one of the main importance of CloudFormation is that someone else can run the code on his own AWS account. So you have to create the parameters regardless of whatever requirement he wants, so he can actually scale in and scale out the values. So let's go on, and I think that's all you need to know about the code creation. The course will be available on the GitHub link provided down below in the description, the YouTube description button, so you can have access to it anytime, anywhere. So that's it. Let's go to the AWS CloudFormation console. So here we are. This is the CloudFormation page. So this is where the resources have been shown. So you drag the resource, you drop it right in here. These are the resources type. This is where your code. This is where you see your code messages in case there is an error. So there are two ways. There are two languages in the CloudFormation understand, JSON or YAML. So the code I'll be uploading as a YAML format. Automatically, anytime you just copy the code, it detects whether it's a JSON code or a YAML code, so it switches itself. But I won't be pasting the code right here. I will be loading the code from here. So you can actually copy and paste the code here. It works perfectly fine. That's what it does. So this is the code, and we have it right here. So this is it. So this is the code, as you can see. This is an elastic IP with a NAT gateway. It's being linked to the private subnet. One of the reasons why we are not creating NAT gateway for our database instance is because AWS manage it themselves. They update it themselves, so you don't need to create it. They will manage it for you. So you check for the validity of the template, because if it's not valid, you cannot proceed further. So it says the template is valid. So let's run it, let's launch it. So what it does is it creates the own resources for you, and you can assemble them. That's what it does. So as it says, the template is ready. You have this. Then let's give the name. That's Oluwaseun. So this, I said it at time. Let's go for micro. So micro is more cheaper than others, since this is just a practical. So tax, okay, let's say my tax, unless you're having much workload to identify. Then rollback in progress. Having rollback or stack is it deals with the file that in case there's an error, it rollbacks everything and it deletes all the resources that have been previously created. But preserve, in case of a failure, other resources are still being created. So that's what it does. So let's click on next. So this is the review session. So you click on this, then you create stack, and here we are. It takes time to create, so it takes so because of presence of the RDS take times to create. So yes, I'm going to pause the video, and when it's done, I'll play it back. So the creation is complete. As you can see, it takes about that's 8 minutes to create the database instance, so it takes a lot of time. The others are just 1 minute. So that's it, and all our resources have been created. So let's take a look at it. As you can see, this is the database. These are the route tables. So let's take a look at our launch templates that have been created. Okay, so these are the launch templates. So it automatically creates an instance for us. Can you see? The instance are up and running, so that is so one for the public, one for the private. So whenever the traffic is very high, it increases to 2. So it creates another 2 instances, additional 2 instances. So the public has a what? A private IP address, as you can see, so it's accessible over the internet. That's it. That is a security group attached to it. So that's everything you need to know, and that's it. Then let's take a look at the database instance. So in database, there's a database. Sorry about the network. So this is our database. So our RDS has been created. As you can see, this is the engine. All we specified so far has been created in accordance. So this is it. Now remember, we created the read replica. So CloudFormation does not really support creating read replica, so you have to create it manually. So you click on instance, click on create replica. So if you want to create a replica, it automatically takes the information of the previous one to create this. As you can see, the information of the previous one, the secret group already attached to it is what it's going to use. So it creates it, and that's it. So we are not creating this actually. So I'm just showing you so that you know how to create it. And that's all we need to know. That's how it works. Nothing more than that. The CPH to use utilization as CloudWash. All these are for the write, IOPS, and read. So let's go back and let's delete all what we have been created. So how do you do that? You just come right in here and click on delete the delete stack. So automatically your stack starts deleting. It takes time for the RDS to delete, the same way it takes time for it to create. So once you have deleted the RDS, you go back to the RDS stage to delete the snapshots, because you just keep incurring charges for the next 24 hours. So that's it. That's all you need to know so far. That's all about multi-architecture. So thank you for joining me. So make sure you subscribe so you can receive update on the next video. Thanks.